Okay, now we've got this other one off at the rear, you can see the difference. This is one journal, part of the crankshaft, but two Conrods run on it, and you can see this bearing is spun and caused massive scratching and damaging to the polished surface, whereas this one is still a perfectly polished surface, and it has oil marks on it, but it's great. That's perfectly fine, nice and smooth, and you can run a new bearing on that no problem. But this one here is hugely scratched up, scored, damaged, and actually you can feel a step going across that way where it's got so much material lost or material displacement. So we've got bearing material which is going around the engine because it's been basically grinding itself away on the crankshaft. It should never touch the crankshaft journal, it should float on a film of oil, but because it's touched that, it's then making metal to metal contact, which is obviously wearing away the metal and also causing the Conrod to wear bad, the Conrod bearing to wear badly. So now we've got the other Conrod bearing out, the one next to it. That's how they are in the car. The bad one is on the left, which is this one, and then the good one, or a one that should look normal, it's worn and it's used, but it is serviceable, and you can see how the width of it, that is a normal width, whereas this one is physically widened because the metal has been displaced and it has to go somewhere, so it flattens and widens. Also you can see the thickness of it, and you've got these locating tabs which are stamped into the metal. It's part of the metal, and that's what keeps it in the bearing, which means that it goes, snaps into, that was the bad one, I'll show you the good one. That was the good one. Those are the little holes in the crankshaft and the cap, in the Conrod and the cap, and those little tabs snap into those locations to make sure that those two pieces stay, one in the cap and one in the Conrod. But on what's happened on yours is that they've been spinning around, rotating, and that's why also the Conrod is badly damaged. This is the Conrod cap, but there's lots of scratches and rotational marks compared to the crosshatch design on this one, because your one doesn't have any tabs stuck in it anymore. You can see there's one tab down there, but there is no tab on the back of this bearing, so it's a bearing failure which has allowed the bearing to slip and spin. So the bearing is broken, the crankshaft is damaged, and also the Conrod is damaged. But like I say, that's what a worn one looks like, and now that's what a spun one looks like, and the spun one has done all the damage. I just wonder if there's any size difference when we put them next to each other. There might or might not be. Yeah, there is, yeah. So that's married up at the top there, and there's a difference in gap down there. And you can see how thin it is because it's been physically squashed together. It's sort of grown width-wise compared to out there. But the main sort of factual information that we're going to need to give you on the report is the clearance gap. So BMW has a set clearance gap, which is normally between 0.025 of a millimetre and 0.076 of a millimetre. So from there to there, anywhere within that sort of range is a good or an adequate clearance, they say. Here's the plastic gauge, which is basically a system which is predetermined sizes of plastic, which you lay a small section of on the new bearing or the old bearing, and then you clamp everything back into the crankshaft and clamp the Conrods back together, tighten through the normal torque process, which is 6 Newton meters, 20 Newton meters, then 130 degree turn. Then you undo the bolts, take the cap off, and then you read off how much sort of width the plastic has been squashed to on this guide or this chart. So let's go and do that now on your engine. Here is, we've put 2 bits of plastic gauge, that's roughly how long they start, one on this broken section or bad section and another one here. This is what we'd normally see, which is a squashed section of plastic gauge, and then you simply use this chart to see how wide the sort of spread is. And we've got probably, on this one here, I'd say that is the closest one there, which is 0.038, which is quite typical, quite normal. On a BMW bearing, you normally see between 0.38 and 0.50. Up at this end, it's a little bit closer to 0.50, but I'd say the majority of this one on the good bearing is 0.038. Whereas you look at this one here, it's hardly been squashed at all because it's physically worn. The gap is obviously bigger and therefore it doesn't get squashed so much. And the closest we can get to is the very end one here, which is 0.0 175, which is a massive gap. No way in the world that that will run properly or at all for a long period of time. I'm absolutely amazed it hasn't been knocking audibly, but there you go, those are our findings. That's how we found the engine. There's a Spun Conrod bearing set on cylinder number 10, and that has basically finished this engine off, I'm afraid. There is no way it can be run. I wouldn't advise starting it again. It can be put back together, that's no problem, it will physically go back together, but I wouldn't recommend running it, because at any stage that Conrod could basically just break off because it's got so much play, could snap the connection bolts and it could just go through the engine. Obviously nobody wants that, but we need to obviously warn you sort of the risks of running it or starting it. So we're going to not carry on and check the rest of them, because it's pointless in our opinion, because that is damaged beyond repair. That crankshaft can't be reused, the Conrod can't be used, and obviously a new bearing set can't go in there, so there's no point spending any more time going through the rest of them, because even if they were all perfect, you're still in the same position where this engine needs either replacing or rebuilding as a minimum.